Hello, honors chemistry students. So sorry I can't meet with you personally today. I'm doing the I-step, so I have recorded the notes for you. So make sure you have submitted the reaction types worksheet 2 that you did in last class period. Make sure you upload that to today's Schoology page. And then the homework tonight will be the synthesis and combustion worksheet, and that will be due next class period. So let me pull up the notes and we will get started. Okay, so from here on out, our all of our problems on all of your future worksheets in this chapter, you will just be given the reactants only. You will no longer be given the products. And based on the types of reactions you are given, you will need to determine what type of reaction it is, and then once you figure out what type of reaction it is, you will predict and determine the kinds of products that that reaction will produce, and then obviously also balance the chemical reaction. So we're going to go at this slow. Today we're just going to look at combustion and synthesis reactions, take an in-depth look at those, and then next class period we'll do decomposition and then continue on from there. So starting with combustion reactions, there's only one possible set of products that a combustion reaction can form. And again, as we talked about last class period, combustion reaction is when we have any kind of carbon compound, and if it's not an alkane, I will give you the formula for that carbon compound. It's going to react or burn with oxygen, and that will always produce carbon dioxide and water. And in our class, there are other types of combustion reactions, but for our purposes in honors chemistry, combustion will always just produce carbon dioxide and water. So anytime you see some kind of carbon compound and oxygen, you know that's a combustion reaction, and so the products will always be carbon dioxide and water. And as I mentioned before, we can have all sorts of examples of combustion: burning the food you eat in your body to keep you warm, wood, gas. So there's all sorts of different types of carbon compounds that react with oxygen to form carbon dioxide and water. So here's an example, and this is again like what all your future homeworks will look like, just giving you the reactants only. So here we have methanol burning with oxygen. Now methanol is not one of the alkanes, so if this were on your homework or test or quiz, I would give you the formula for methanol, which that is CH3OH. And you only have to know the alkanes. Any others, I will tell you what those formulas are. So CH3OH, and then our other reactant is oxygen. So recognizing that this is a carbon compound reacting with oxygen, you're going to know that's a combustion reaction, so it's going to form carbon dioxide and water. And then we just balance it, so make sure you always check. So make sure you always check and make sure that you've got the reaction balanced once you write out the products. So here, our carbons are balanced. We've got four hydrogens. So if I put a 4 here, or again a 2 here, then that gives us 4 oxygens on the product side, but only 3 oxygens on the reactant side. So again, this is an example of where we have this odd amount. That's going to make it challenging to balance. So I'm going to double that, which now gives us 2 carbons. So I'm going to fix that first. So there's our 2 carbons. And then I'm going to go back and fix our hydrogens because those changed as well. So now we have 6 plus 2 more. So we have a total of 8 hydrogens over here. So let me erase. And put up 4. Oops, I lost my plus sign when I erased. There we go. So now we have 8 hydrogens over here. And then let's check our balancing. So we have 4 and 4, 8 oxygens. We have 2 already here in the methanol. So we need just 6 more. So I'll put a 3. Okay. So again, this is a combustion reaction. We have a type of carbon compound reacting with oxygen, forming carbon dioxide and water. Okay, so our next group of reactions are all synthesis or combination, whatever you want to call it. We have 4 different types of synthesis reactions based on the starting materials, based on the different types of reactants, but regardless of what the reactants are, remember synthesis reactions always form just one compound as a product. So all of these will have just one product. All right, so our first type of synthesis reaction, which is really a true combination reaction, is where we're basically just combining 2 what we call free elements. Those are, just individual elements. They could be diatomics also, but 2 elements just in their natural state, and they are forming an ionic compound. And so with an ionic compound, we have to remember to crisscross the element's charge. So again, that's our one product, is this ionic compound. So as an example, we have magnesium reacting with oxygen. So magnesium, and it may also say maybe magnesium metal, but that's just plain old Mg. We're not going to worry about listing our states of matter. And then it reacts with oxygen. And just like up here, oxygen is diatomic when it's by itself. So that's all that the problem gives us. So looking at these are 2 individual elements in their natural state. We know this is that first synthesis reaction, and the 2 elements are going to combine together to form an ionic compound, which again we have to crisscross our charges in our ionic compound. So magnesium, being in group 2A, makes it have a +2 charge. Oxygen in group column 16, it has a -2 charge. So the 2's cancel, and that just gives us MgO. And we still want to make sure we balance. So to balance this, since we have 2 oxygens here, we need a 2 and a 2. Okay, so we have 2 individual elements. They're just going to combine into an ionic compound, which we always write the metal or the positive ion first, and crisscross our charges. In this case, our charges cancel. Okay, so that's our one product that makes this a synthesis reaction. Our second type of synthesis reaction is where we have a metallic oxide. So that's a compound made up of a metal and oxygen. That's why it gets its name, metallic oxide, and water, which you all know water, H2O. Those are our reactants, and when they combine together, they will form a single product called a metallic hydroxide, which is also known as a base that we'll talk about in our acid-base chapter at the end of the year. So metallic hydroxide is a metal with hydroxide, the polyatomic ion. That's our one product. So an example of this, and again, this is all you're going to be given on your homework, or just the reactants. So you've really got to look at the types of compounds or elements that the reactants are. So we have aluminum oxide. Aluminum's a metal, and oxygen, so that's a metallic oxide, and water. So that's your indication, metallic oxide and water. This is that second synthesis reaction. That's going to make a base or a metallic hydroxide. So let me get my little pen up here. Okay, now anytime we have a metal, we've got to crisscross charges. We have an ionic compound. So aluminum is +3, oxygen is -2, so that will give us the compound Al2O3. So that's our metallic oxide, and then water. And those two compounds are going to combine together to make our metallic hydroxide. So again, our metal is, in this case, is aluminum. Still has a +3 charge, and then hydroxide is polyatomic OH-. So when we crisscross their charges, that will give us AlOH3. Okay, so that's our metallic hydroxide, or a base, whatever you want to call it. And then again, we need to make sure we balance these. So here our metal has 2 aluminums on the reactant side, so let's put a 2 there. And then hydrogens, that's going to give us now 6 hydrogens over here on the product side. So I'll put a 3 here, sorry, to make a 6. And then in this case, our oxygen's automatically balanced. So there's our balanced reaction. But again, we started out with a metallic oxide, so metal, oxygen, metallic oxide, and water. And that's your indication that that will form a metallic hydroxide, or a base. And again, we need to remember crisscross charges anytime we're dealing with a metal. Okay, our third type of synthesis reaction, similar to the second one, only this time we have a non-metallic oxide and water as our reactants. So non-metallic oxide, those are on the right side of that little stair step on your periodic tables, that little corner over on the right-hand side. And oxygen, now because it's a non-metallic oxide, we're going to see the prefixes in the name because we're not crisscrossing charges, we're just combining random amounts of nonmetals and oxygen together. So you'll see prefixes, and then they're going to combine together and form an acid, which again, as we learned way back in November, acids start with hydrogen. So an example of this is sulfur dioxide. Again, these are molecular compounds. We're not crisscrossing charges, so you'll see the prefixes reacting with water. Now, the nice thing about these is I will give you ones that all you have to do is combine everything together to get your acid. There are more complicated synthesis reactions where you would have to do a little more calculating or whatever to come up with what the acid should be. But for all of the ones I'll give you in honors chemistry, you just have to combine the non-metallic oxide and the elements in the water to get your acid. Okay, so what that's going to look like is sulfur dioxide is SO2. Again, there's no crisscrossing. This is a molecular compound, just combining, in this case, 1 sulfur, 2 oxygens, and then our water. So again, to figure out what the acid is going to look like, we're just going to combine all of this together to make it a ternary or an oxyacid, which is, as we talked about back in November, an acid with a polyatomic. So we write our hydrogens first, and with the water we have 2 of them. And then we make all the other elements, combine them together to make a polyatomic, which we have 1 sulfur and 1, 2, 3 oxygens, so that would be SO3. So when sulfur dioxide and water combine together, they form sulfurous acid, H2SO3. And the nice thing about these, since we're just combining all the elements of the reactants together to make our acid, these are already balanced, so we don't have to worry about any balancing. Just make sure you write your acid correctly. It'll be some ternary acid, and we always write the hydrogen first and then make the polyatomic out of the remaining elements from the reactants. So again, don't worry, there's no balancing with these. Okay, so those are pretty simple to do since you don't have to worry about balancing. And then finally, the fourth type of synthesis reaction is where we take a metallic oxide and a non-metallic oxide, and those combine together to form what we call a salt, which a salt is just a generic name for an ionic compound, and in this case it'll be an ionic compound made up of a metal and a polyatomic ion. Okay, so the product we get is going to contain a metal, which we always write the metal first, and then some negatively charged polyatomic ion. Okay, so here's an example. Carbon monoxide, that's our non-metallic oxide because carbon's a nonmetal, and we have the prefixes here, so our carbon monoxide is our non-metallic oxide. Sodium oxide, sodium's a group 1A metal, so that's our metallic oxide. Okay, so when we see that, we have two different oxides, a metallic oxide and a non-metallic oxide. That's our indication that this is a synthesis 4, and the two of these compounds are going to combine together and make a salt or a metal combined with a polyatomic ion. Okay, so we write this out. We have carbon monoxide, which is just CO. Again, there's no crisscrossing or anything with our non-metallic oxides. They're just combining together in random amounts. And then our sodium oxide, that one with the metal. Remember, anytime we have a metal, we do have to crisscross our charges. So since sodium's in group 1, that it has a +1 charge. Oxygen again has a -2. So our metallic oxide is Na2O. So our metallic oxide, non-metallic oxide going to combine together, make a metal and a polyatomic. And very much like up here with our non-metallic oxide and water forming an acid, where we just combine these all together to make the acid, we're basically going to do the same thing down here with this fourth synthesis reaction. We're going to combine it together to make this salt. So we have our metal, and then what remains forms our polyatomic ion. So we have carbon, and then a total of, in this case, 2 oxygens, which is the polyatomic carbonite, and that's where this 2 comes from. It looks like we didn't crisscross, but we really did, because carbonite, CO2 that we get from the remaining elements, has a -2 charge, so the 2 comes down here. So both of these last 2 synthesis reactions should automatically balance, because we're just taking all the elements from the reactant side and combining them into either ternary acid or into an ionic compound that contains a polyatomic ion. So you won't see a whole lot of these. The majority of synthesis reactions that you'll see are these first two individual elements making an ionic compound, or a metallic oxide and water making a metallic hydroxide. Because there's only so many combinations for these last 2 synthesis reactions that I can give you that will work out. But these last 2 will always balance out on their own, since we're just combining everything into the format. But make sure you're writing the salt properly with the metal first and then the polyatomic second. Okay? So that's it for our notes today. I'm going to do the corresponding homework, the synthesis and combustion worksheet. And again, on all of those, it will just give you the reactants only. If you want to, you can write off to the side that it's a combustion or a synthesis 1, 2, 3, 4. I'm not really going to look at that, because I will know that you determined what type of compound it was based on your products. So I'll just be looking for, did you come up with the correct products? And did you get the reaction written out and balanced correctly? But if it helps you to label them as combustion, synthesis 1, 2, 3, whatever, please do that if you find that helpful. And that will be due next class period. So be ready to turn that in when we meet next time. There's also a fun little video for you to watch that shows me doing a demonstration with of a combustion reaction. So once you finish these notes, take a look at that. I think you'll enjoy it. It's kind of cool. And I will see you next time. So have a good day. Bye.